Hi all, welcome to the presentation on Deciphering JavaScript. In this session, we are going to look at how we can understand JavaScript and its fundamental. So let's kickstart. So if we look at how does client-side JavaScript work, we first need to understand what makes JavaScript as a whole. So let's figure that out. So what is JavaScript?
So JavaScript is basically a single-threaded, non-blocking, asynchronous, and concurrent programming language. Okay, so let's keep that in mind and move forward. And what does JavaScript have? JavaScript has a call stack, event loop, callback queue, and other APIs. So all these together make JavaScript. So we need to understand each one of these components make up JavaScript. So we need to understand each one of these components in order to understand how JavaScript works. So in this session, we will be mainly focusing on JavaScript on V8 runtime, where that is the JavaScript runtime on Chrome. So let's move on. So the V8 contains a call stack and a need. So let's first go through each one of these items separately to understand, how each of these components contribute towards getting our tasks done with JavaScript. So let's look at the call stack, which is one of the most important and fundamental components of any language. So let's first see how does the call stack actually stacks up all our requests. So in this case, we are looking at a simple demonstration. So we call a function print square, which actually internally calls another function square, and that function calls multiply, and you get the result, and that gets output in the console. So let's see how it works. So first, the main program kicks in for execution. Then comes the print square with whatever the value that is passed in, and then the square function is called with the value that is passed in from print square, and then the multiply function is called with a couple of more parameters. So the first method to get evaluated and complete is multiply, and it returns its result to square, and square returns the results that it receives from multiply, and then the value is assigned to the square variable, and then the console.log function is called, and whatever the value that is held by a square variable will be print out. So you will see that value in the console if you open the console in Chrome. Okay, so then the execution exits. So likewise, if you look at a call stack, when you throw an error, when an error is thrown in one of your functions, you will see that Chrome console actually outputs all the items in the stack at that point. So for an example, in this case, the first method to call is base, and that calls bar, that calls foo, and foo throws an error. And on the right hand side, if you see, it shows the call stack based on how the initialization happened. So this is the call stack, the status of the call stack when the error was thrown. So let's move on to the next thing. So there is something called blowing the call stack. That is the call stack as limited space basically. So you can actually blow it up. So in Chrome, I think the default stack size is something around 16,000. So if you go beyond that, basically the browser will throw an error that you did not intend to call this method this many times. So on behalf of you, I'm breaking up the execution so that we'll have to take care of the bug that is in the code. So let's look at how it happens. First, the main method is called, Then comes the foo method, which returns the foo method again. So it recursively keeps calling the foo method on. And at one point it throws an error. The maximum call stack size exceeded. So which means comes, takes us to a next point, that is we, as JavaScript developers, we have always heard about this blocking code. So first of all, what is blocking code? Blocking code is basically nothing but code that takes a long time to execute. For an example, a console.log is not a blocking code because it executes instantaneously. But if you do a image processing, or if you make a AJAX request to another API, that's called a blocking code because it takes time to get back the information or complete the processing. So if you loop through 1 billion items, that is again a blocking code basically. So let's look at how blocking code is executed, and the state of the call stack when such a long running code is executed in JavaScript. So these are synchronous calls basically. So let's see how it works. So the main program kicks in, and you have a call to get sync. So you wait until foo.com returns a result to you, and then the next call kicks in, which is again bar.com. So the execution waits till the bar.com returns a response, and then the next sequence goes on, and so we wait again, and then console.log foo, console.log bar, and console.log qx. Yes, so one of the main issues with this is that since the call stack is not empty till the AJAX request or a long-running code is executed, one of the fundamental things with the browser is that it keeps it renders itself every few milliseconds. So that execution only happens when the call stack is empty. So since there is a long-running code in the call stack, the screen won't get repainted over and over. So because of that, if we do this in JavaScript, we would see a very frozen screen while that operation completes, and which won't be helping us to create a fluid UI in the browser. So let's look at a quick demo. I'll show you what happens when we run a long-running code in the synchronously. So let's move on. Okay, so let's look at this example over here. So as you can see, I have a sample web page. It shows some text, and I have a button which a link I can click, and it shows a pop-up message. And I have a button. When I click on this button, it's going to make a request to one of the sites in the web. And during that site, that request goes on, I won't be able to select a text or click on this link to get a pop-up or anything like that. Even if you will see that until the execution completes, the button also will be in a clicked state. So I'm going to demonstrate that now. Yeah, so as you can see, the execution altered till this code got executed. So what is the what do we do to actually overcome this issue? So there is something called async callbacks or asynchronous callbacks. which is actually a solution that comes to rescue us in this situation. So let's see how we can use async callbacks to pull us from this obstacle. So let's look at this code in the first place. So so set timeout is again a function which allows us to run a piece of code after a certain delay. So let's see how the call stack works with this kind of asynchronous and callbacks. So let's kick in the execution. So the main program starts execution, and console.log is printed, and then comes set timeout, and the set timeout disappears all of a sudden, and console.log appears in the call stack. And let's move on. Yeah, so as you can see, console.log there has appeared from nowhere. So how does this happen? So basically what happens is, so there is something called event loop, which allows the browser to do this. So let's look at how event loop works. So so in JavaScript, in Chrome, the V8 runtime, the browser plays an important role. So the browser basically gives us certain web APIs, which are basically APIs like set timeout, XHR, that execute in a different thread basically. So let's see how that works. So I've actually created a small presentation which actually depicts how this happens in the background in JavaScript. So let's execute. So as you can see, the stack is the call stack where all the method calls will be stacked into, and web APIs is basically let's imagine as a separate thread given by the browser that let's say keeps track of the timer and also any XHR request. And the moment the web API completes execution, it will hand over the callback function to the task queue. So let's see how this works. So the main program kicks in, and we have the console.log printed in the stack, and then comes the set timeout function. And the moment the set timeout function comes in, it gets added into the web API because it understands it is something that should be handled by the web API. So that function is passed on to the web API, and the web API keeps track of the time or the interval. So the moment the interval exceeds, it will be added to the task queue. So the stack can go on with the rest of the execution basically. So console.log is is printed, and then the moment web API the interval is exceeded, the task queue gets a request from web API, and then the main role of the event loop, it plays a primary role, but the main role of the event loop is that it'll it'll basically check whether the stack is free, and if the stack is free, it will execute, or it will actually hand over the execution to the first element in the task queue. So since we have the callback function in the task queue, so the event loop will hand it over to the call stack, and the callback function will be executed. So this is how the set timeout function basically works, and it is in the same manner that URL callbacks also work. So in the if you see the same example, I've changed the set timeout to a basically a GET request to one of the URLs. So if you see, the main program kicks in, and the console.log I is printed, and you have a get call and it goes into Web API for execution to retrieve whatever the data that we want to get from that URL, and the rest of the code gets executed. Foo is added. Once it is complete, the Web API passes that information to the callback function to task queue. The event loop checks whether the stack is free, and the data is printed on your console. So this is how call stack, Web APIs, task queues, and event loop work in tandem to do what we want to do with JavaScript in the browser. So if you're actually using Node.js, basically, these web APIs will be replaced by C++ APIs available in Node.js. One of the cool JavaScript developers has developed this tool called Loop, which actually depicts how these callback functions work, and how does the browser repainting works and things like that. So I'll show you a quick demo to make you further understand how it works in real time. So let's move on to the demo. So as you can see, I have a simple array of 4 elements. So I'm going to loop through those elements, and I've put a delay actually. So just to make you understand, how it executes in real time. Also, so I've said the simulator, in order to simulate the re-rendering also, there is a small tick. So once you add that, the re-rendering also tries to happen. So let's see how this works. So basically what would happen is the array will go through each item one by one, and the delay function will actually delay the execution. And let's see how it actually works. Yes. So now I'm going to add the browser simulation as well, and I'm going to resume execution. So as you can see, until the call stack is empty, the rendering queue actually does not do anything. It all sits its execution. It waits for the item in the call stack to complete. So this is the same behavior that we see when we click on a button and we make a synchronous call to a URL. The entire screen freezes in the browser. So we won't be able to create a fluid UI experience to our clients. So let's look at a bit more complex scenario. So so the same thing that we did in our previous example, we are going to improve it by using set timeout. So that I can actually show you how set timeout comes into rescue and allows the browser to re-render itself while something long running happening in the background. So let's take this button, and I'm going to run this code. Okay, so as you can see, at every few milliseconds, the browser is able to re-render itself, and at the same time, the code that we have written, the long-running code, also executes. So this basically delays the execution of the code, but still, that's something acceptable because the browser is not frozen, and we are able to give a better experience the users who use the system. And finally, one more thing about the set timeout function. So the interval that we add in the set timeout is basically the minimum time of execution. It's not an exact time of execution, because you could there could be code that is running in the stack, which would actually prevent the event loop from executing your code, even though your code is in the callback queue. Yeah, so that's basically the things I wanted to cover in this episode. So I hope I managed to give you guys some insights as to how JavaScript works. Yeah, thanks for joining.